Hello, my name is Brendan Harrison, and I'm enrolled in the Business Analytics and Information Systems major at University of South Florida. This is the first submission out of a total of 4 to qualify for the Muma College of Business Citizen Data Science Certificate. This assignment is submitted under ISM 3232, taught by Professor Clayton Daniel during the fall semester of 2018. The purpose of this video is to briefly explain a few insights and stories that I discovered from a dataset that relates to business application development. Before I begin explaining my visualizations and insights, I will quickly explain the data source I used for this assignment. The data source I utilized comes from a survey that was conducted between December 11, 2016 and February 10, 2017. The goal of the survey was to ask employees from various organizations in separate software industries the number of different programming and software architectural styles they used in projects. Additionally, survey respondents provided their name and type of degree they currently had at the time of the survey. In order to develop a general starting point for exploring my data, I only used one measure in my first visualization, which happened to be the average number of object-oriented styles used in projects across the 3 industries. Throughout my worksheets, I used averages rather than sums because sums did not provide as much insight, in contrast to using averages to compare industries. With that in mind, I then proceeded to generate my first worksheet and found a few insights regarding the average number of object-oriented styles in different industries. First off, industry number 2 had a dramatic increase in the average number of object-oriented styles used in projects from 2016 to 2017. What is also interesting is how industry number 3 did not use object-oriented styles in any projects for the entirety of 2016. After discovering the surge in average number of object-oriented styles used by industry number 2, I wanted to dig deeper and uncover the top organizations that contributed for the increase. To find this, I swapped out the side-by-side bars I used previously in favor of a tree map to condense the number of organizations in the second industry. I filtered by 2017 only and created label marks for the year, organization, and average number of object-oriented styles, and implemented a color mark for the average to make it easier for viewers to see the top contributing organizations. Examining this worksheet reveals how organizations 68, 98, 82, 74, and 78 were the top 5 companies contributing to that initial increase in the average number of object-oriented styles used in industry number 2 between 2016 and 2017. For my third worksheet, I wanted to find more information about those 5 organizations from the second worksheet. To do so, I started a new analysis using a different measure, that is, the average number of function-oriented styles. The reason I chose this measure is because of the research I found concerning the history of function and object-oriented styles. In short, there is a widespread schism among programmers regarding which style is better for creating programs. Function-oriented programmers often argue that function-oriented styles are better because there is a complete separation of the data and the behaviors of a program. They also argue that it leaves less room for error because programmers must adhere to pure functions that receive inputs and generate outputs while not producing any side effects. Object-oriented programmers argue that object-oriented programming is better because it lets programmers structure their program using objects and methods, which makes the program more flexible and allows for greater modularity. Knowing that then, the viewers watching this video can immediately notice how my third visualization produced insights similar to the first one I created, but instead with the average number of function-oriented styles as the measure. My fourth visualization continues my third worksheet by utilizing a format similar to the second visualization, but again, using the average number of function-oriented styles as the measure. The top 5 organizations with the highest averages for function-oriented styles were 98, 78, 81, 74, and 79. What is significant about this visualization is how organizations 98, 78, and 74 were a part of the top 5 companies with the highest averages for function-oriented styles in industry number 2, and were also a part of the top 5 companies with the highest averages for object-oriented styles as discovered in the second worksheet. This major insight arouses questions concerning those 3 organizations, such as whether they have a diverse set of programmers who have experience and knowledge with both object and function-oriented styles. Perhaps having programmers who can use both styles is what gives those 3 organizations their individual competitive advantages. Maybe the other organizations besides the 3 aforementioned companies have programmers who are biased towards other programming styles. And here simply is my dashboard where you can view all of my visualizations I've created and the insights they produced. Again, you can see across the 4 worksheets the impact Organizations 98, 78, and 74 had in industry number 2 by increasing the average number of object and function-oriented programming styles from 2016 to 2017. With that in mind, this concludes my presentation in some blue for ISM 3232. My name is Brennan Harrison, and thank you for watching.